Oracle Database Storage, Understanding Core Concepts and Advanced Management Lecture, script for Mr. Bell, Ctech, CaesarBrotherTech.com. Good morning, everyone, and welcome to our comprehensive lesson on Oracle Database Storage. I'm Mr. Bell, and I'll be your guide through this fascinating journey into the heart of how Oracle manages data persistence. Introduction. Today, we're going to dive deep into Oracle's storage architecture, the foundation upon which all database operations depend. Whether you're building small applications or enterprise systems, understanding storage is critical to designing high-performance, scalable, and reliable database solutions. By the end of this session, you'll have a thorough understanding of core storage concepts and building blocks, physical and logical storage structures, advanced table space management techniques, ASM, automatic storage management, architecture, performance optimization strategies. So let's begin this exploration of what happens beneath the surface of every Oracle database. Part 1. Understanding Oracle Database Storage, Core Concepts. What is database storage? At its most fundamental level, database storage is how we persistently save and organize data on physical devices. Think of it as a sophisticated filing system with several crucial requirements. 1. Data persistence. Your data must remain safe even when power is lost. 2. Data consistency. The information must remain accurate and reliable. 3. Performance. Access to stored information needs to be fast. 4. Scalability. The system must allow for growth without major restructuring. 5. Recovery. We need mechanisms to restore data in case of failures. All of Oracle's storage structures are designed to meet these requirements. Building blocks of Oracle storage. Before we dive into Oracle's complex storage structures, let's understand the fundamental units, starting with the smallest and building up. 1. Oracle block. The Oracle block is the smallest unit of I/O in Oracle. Think of it as the atom of Oracle storage. Drawing on board block structure diagram. A typical Oracle block has size, usually 8 KB, though it can be configured from 2 KB to 32 KB. Structure. Block header contains metadata about the block, table directory, maps data to specific tables. Row directory locates specific rows within the block. Free space, available area for new data. The block size decision is critical and impacts performance significantly. Too small and you have excessive I/O overhead. Too large and you waste space with partially filled blocks. Debari War 2. Extent. An extent is a contiguous group of Oracle blocks. Oracle allocates space in extents rather than individual blocks for efficiency. Drawing on board multiple blocks forming an extent. Why use extents? They improve space management efficiency, reduce fragmentation, optimize I/O operations by keeping related data physically close. We have several types of extents. Initial extent, the first allocation when an object is created. Next extent, subsequent allocations as the object grows. Minimum extent, the smallest allowable extent size, no pro. 3. Segment. A segment is a collection of extents that together form a specific database object. Drawing on board multiple extents forming a segment. Oracle uses different types of segments. Data segment stores table data. Index segment stores index structures. Temporary segment used for sorting operations. Undo segment stores information needed for transaction rollback. Physical storage architecture. Now let's look at the overall storage hierarchy. Storage hierarchy, drawing on board storage hierarchy from logical to physical. Table space level. Logical container for segments can span multiple data files. Common types include system, sysux, temp, users. Data file level. Physical files on disk contains the actual data blocks, can be fixed size or auto-extensible. ASM disk group level. If using ASM, collection of disk devices, manages redundancy, handles striping and mirroring for optimal performance. Let's examine the Oracle block structure in more detail. Showing detailed diagram of Oracle block structure. Common header, 100 bytes. Contains block address, SCN, system change number, status flags, variable header, 200 bytes. Contains transaction tables and ITL entries, table directory,
Maps row pieces to tables. Row directory. Contains row addresses and status information. Free space. Available for new data. Managed by PCT Free and PEC-Tust. Row data. Where the actual table data is stored in an 8 KB block, only about 7.7 KB is actually available for data storage due to this overhead. Yerashrat. Part 2. Understanding Oracle Database Storage Structures. Yenorwar Storage Space Management. Now let's dive deeper into how Oracle manages extents and segments. Shardwars Extents Deep Dive. Drawing on board extent allocation process. We classify extents as user extents, store table index data. Temporary extents, used for sorting operations. Undo extents. Store undue information regarding extent management. Oracle provides two approaches. Dictionary managed. Uses data dictionary tables. Older method. Locally managed. Uses bitmap in data file. Modern, recommended approach. The locally managed approach reduces contention and improves performance. Segments. In-depth segments are the database object storage allocation units. Different types serve different purposes. Data segments, store table data, index segments, store index structures, LOB segments, store large objects. Temporary segments. Used for sorting workspaces, segment space management happens in two ways. Manual. Uses free lists and free list groups. NOS automatic ASSM. Uses bitmap to track block usage. Recommended. Doanurabasa high watermark HWM. Drawing on board high watermark concept. The high watermark is a crucial concept in Oracle storage. It represents the point beyond which no blocks have been used in a segment. This concept is important because it affects full table scan performance. It impacts space reuse after mass deletes. It's key for segment shrink operations. Let me show you some essential commands for monitoring segments and extents. SQL, view segment information, select segment name, segment type, extents, blocks, bytes, 1024, MB from DBA segments. Where owner and schema name, monitor extent allocation, select segment name, extent ID, bytes, 1024, MB, blocks from DBA, extents, where owner, schema name, order by segment name, extent ID, check high watermark information, select segment name, blocks, empty blocks, num free list blocks from DBA segments, where segment name, table name. What are storage parameters? When creating tables and indexes, you can specify several storage parameters. Initial, size of first extent, best practice, size for 3 to 6 months growth. Next, size of subsequent extents, best practice, equal to initial for uniform growth. Mine extents, minimum number of extents, default 1, usage, pre-allocation of space. Max extents, maximum number of extents, best practice, unlimited for modern systems. PECT increase. Growth rate of next recommended 0. Prevents exponential growth. Free space management. Oracle manages free space within blocks using two key parameters. PCT free. Space reserved for updates. Purpose. Prevent row migration. Default 10%. Consideration. Set higher for tables with frequent updates. PC-TUSed. Threshold for new insertions. Purpose, space reuse efficiency. Default, 40%. Impact, controls when a block becomes available for inserts again. You can monitor block space usage with these commands. SQL, check table space usage. Select table, name, blocks, empty blocks, AVG space, chain, CNT from DBA tables, where owner, the schema name, monitor row movement, chained rows, select owner, table name, chain.cnt, AVG, row, then from DBA tables, where chain.cnt, 0, order by chain.cnt, desk, analyze block usage, analyze table, schema, table name, compute statistics. Now, Part 3, Advanced Oracle Storage Management. Table space management and configuration. Table spaces are logical storage units that group related database objects. Oracle provides several types of table spaces for different purposes. Barbies, types of table spaces, drawing on board, table space types and relationships. 1. Permanent table spaces. 9. System, core data dictionary, never take offline. SciSaw, Secondary system tablespace. Users, default for user objects, use custom. Application-specific tablespaces. 2. Temporary tablespaces, used for sort operations, session private sort segments, temporary tables. 3. Undo tablespaces, stores undo information, supports read consistency, enables flashback operations. Tablespace attributes. 1. Space management method. Locally managed, recommended, uniform, fixed extent size, auto-allocate, system-determined sizes, dictionary managed, legacy, uses data dictionary tables, higher overhead. 2. Segment space management, automatic, ASSM, uses bitmap to track free used space, reduces contention, better space utilization, manual, uses free lists, higher maintenance. Let me show you some essential table space management commands. SQL, create a locally managed tablespace, create tablespace user, data file, U01, Aura data, user, data01.dbf, size 100 mers, auto extend, on extent management, local segment space management auto, add a data file. Alter tablespace, user, data, AD, data file, U01, Aura data, user, data02, dbf, size 100 mers, monitor space usage, select tablespace name, round, total bytes, 1024, 1024, 2, total MB, round, free bytes, 1024, 1024, 2, free MB, round, used bytes, 1024, 1024, 2, used MB, round, used bytes, 100, total bytes, 2, used PC'd from, select tablespace name sum bytes, total bytes, sum decode, max bytes, EU bytes, max bytes, sum bytes, NVL free bytes, EU0, used bytes, sum NVL free bytes, E0, free bytes from, select tablespace name, bytes, max bytes, select sum bytes, from DBAC free space, F where F, tablespace name, issue D, tablespace name, free bytes, from DBA data files D, group by tablespace name, no for words, ASM storage architecture and management. Oracle's automatic storage management, ASM, is a volume manager and file system designed specifically for Oracle database files. Variety ASM components, drawing on board ASM architecture. 1. ASM instance. Purpose, manages ASM disk groups, components, SM on, instance recovery, RBAL, rebalance master, ARBN, rebalance slaves. 2. Disk groups. Types, data, database files, reco, recovery files, arch, archive logs, redundancy options, external, no ASM mirroring, normal, two-way mirroring, high, three-way mirroring, null ASM file, types 1, fully qualified file names, 2, numeric file names, 3, alias file names, no runs, ASM features, 1, dynamic rebalancing, automatic redistribution of data, online operation, configurable rebalance power. 2. Fast mirror resync. Tracks change regions, reduces resync time. Here are some key ASM management commands. SQL, create disk group, data, normal redundancy, fail group, FG1, disk, dev, SDC1, name data, 1000. Fail group, FG2 disk, dev, SDD1, name data, 1001, add disk to group, alter, disk group data, add D disk, dev, SDE1, name data, 1002. Check disk group status, select group number, name, state, type, total, MB, free MB from VASM disk group, monitor, rebalance operations, select group number, operation, state, power, actual, S minutes, S rate from VASM operation, Jaswarish storage performance optimization. Optimizing Oracle storage performance involves several key areas. Jaswarish key performance areas. 1. I/O distribution, separate data files across devices, balance I/O patterns, monitor hotspots. 2. Block and extent management, optimal block size selection, extent size configuration, free space management. 3. ASM optimization, disk group configuration, rebalance power settings, failure group design. Let me show you some queries to monitor storage performance. SQL, check I/O performance, select file or firewords, round fgeodem 100,2 avg ioms from v filestat f, the data file d, where f.file os, d file os, order by fgeoteam desk, Monitor ASM performance. Select A.name disk group B path. B reads B writes round. B reads each time. B reads neuro. AVO readims round. B write time. B writes AVG writems from VASM disk group A. VASM disk B where A group number. EQ B group number and B reads plus B writes E0. Check table space IO. Select T is table space name. Sum effords reads sum F words writes round sum F read time. Decode sum effords 01 sum effords 2 AVG read M's from a file stat F DBA data files T's where F file eins T's file ID group by T's table space name order by reads plus writes DESC EC part 4 operating system disk preparation for ASM. Now let's move to a more practical section, how to prepare disks for ASM in a Linux environment. Linux environment, step-by-step preparation. Step 1, initial package installation. First, we need to install the necessary packages: bash, rootedb server, yum, install oracle asm, rootedb server, yum, install kmod oracle asm. When successful, you'll see output confirming the installation. Itjas and such. Step 2, disk identification. We need to identify the disks that will be used for ASM. Bash rootedb server. Isno lsblk name. Maj min rm size. RO type mount point SDA 8100 50G0. Disk plus SD1 801 0500 min 0 part. Boot plus SDA2 8.20 49G0 part. Plus SDA3 8.30 500 min 0 part. Swap SDB 816 100G 0 disk. Nogger new disk for ASM. SDC 8.32 100G 0 disk or a new disk for ASM rootedb server. AFI, FDisk, L, or grep, disk. See you in the next video.